The India International Science Festival, IISF, is a grand celebration of India's achievements in science and technology. It is an initiative driven by the Honorable Prime Minister Narendra Modi ji, as a part of his vision of utilizing scientific research to serve humanity. The 10th edition of IISF will take place at IIT Guwahati, Assam, from the 30th of November to the 3rd of December 2024. IISF 2024 is being conceptualized by the Ministry of Science and Technology and coordinated and organized by the Council of Scientific and Industrial Research, CSIR, in association with other government departments and Vigyana Bharati. IISF stands as a symbol of inspiration and collaboration, offering a unique platform for scientists, researchers, students, and science enthusiasts to share knowledge, exchange ideas, and forge new connections. The theme of IISF 2024 is Transforming India into an S&T-driven global manufacturing hub.
The journey hereafter and the journey from here onwards is going to be primarily technology-driven.
IISF 2024 aims to foster a prosperous Bharat in harmony with modern infrastructure and nature, ensuring opportunities for every citizen to reach their potential through science and technology. This year's festival will feature 24 distinct events. Some key highlights include Focused S&T for the Northeast, Museum of the Moon, Global Manufacturing Summit, Students S&T Village, New Frontiers of S&T for Viksit Bharat 2047, Women in S&T, From Development to Leadership, Empowering the Youth, Mission Startup, Minister Secretary CEO Conclave, Reimagining Bharat Exhibition, International Science Literature Festival, Science Through Games and Adventures, Northeast Food Street, LED Light Show, and Northeast Cultural Fest. Join us on this extraordinary journey into the world of Indian science, technology, and innovation. Be part of this historic movement. Explore, learn, and embrace the wonders of science at the India International Science Festival 2024. Visit our website at www.iisf.
And 423 636 3625. অনেক স্টুডেন্ট ছিল অনেক চলতে সালে বলছি সেটাই আমার এইটাতে গিয়ে দাঁড়িয়ে দিছি বলছে না সুস্থ করলে বলছে সাইন্টিফিক জানে স্যার আমরা স্যার লিখে পাঠান ও আচ্ছা ওইটাকে আগে ডিলিট করে হ্যাঁ 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 স্যার তারপর চলো 668
368
হ্যাঁ
1689
1689
হ্যাঁ
হ্যাঁ ওই ইউটিউব লাইভটা ঠিক আছে স্যার স্যার ভিডিওটা চলছে কি দেখো দেখ ফোল্ডারটা নিয়ে দিয়ে দিয়েছিল না স্যার পাল্টেছিল তো ফোল্ডারটা নিয়ে এটা তাহলে আরেকটা ফোল্ডার রাখ ওটা ডিলিট করে দিলাম স্যার আগে ডিলিট করে দিতে তাহলে আপলোড করুন চলুন এটা শুনতে তাহলে সিপিআই লিখতে করব সিপিআই হ্যাঁ ক্যালকুলেট করে দিচ্ছি এইটাকে অটোমেটিক এটাকে অফ করে দাও তো খুব অসুবিধা হবে বুঝলে চলে যায় না নিচের কেটে থাকে অটো হাইট দিয়ে ওইটাকে হাইট করে দেবে এটা ঠিক আছে এই যে এটা খুব অসুবিধা করে জানো তো এটা প্রেজেন্টেশনের সময় বড্ড অসুবিধা করে এটা বুঝতে পারছি। এই বারটা কাজ করে কারণ আমাকে একটু মাউস ইউজ করতে আমি স্যার ইয়ে করবো আমি চালিয়ে দেবো আমি চেঞ্জ করবো ঠিক আছে মাউস দিয়ে এটা করবো তো হ্যাঁ করে দেবো আমাকে মাউসে দেখতে হবে তুমি আমার পেন ড্রাইভ তো দাও ও হ্যাঁ পরে তো দেখো আসছে 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 সব করছো কেন শুরু করেছো শুরু করেছি শুরু করেছো শুরু করেছে দুটো স্টপ দেখাচ্ছে কেন জি দুটো স্টপ দেখাচ্ছে কেন লাস্টে কোনটা স্টপ ওটা স্টপ এবং একটা অপশন
ঠিক আছে
কেউ জয়েন হয়নি স্যার এটা
তোমরা মেন্ডেল ম্যানেজ করবে তো
হ্যাঁ হ্যাঁ
ডাকছেন স্যার ডাকছেন জিতেন্দ্র স্যার ডাকছেন পর্দাটা লাগিয়ে তো ডান Good afternoon and a warm welcome to all of you, all students, faculty members from various schools and colleges, and everyone present here. I earnestly request everyone to kindly take their seats and keep your mobile phone in silent. I request all the participants who joined online, please mute your microphone. I also like to take opportunity to welcome all the dignitaries who already joined or who will be joining us online for their gracious presence. It is my pleasure to welcome you all on this under the banner of Curtain Raiser Program India International Science Festival, which we known as IISF 2024, which will be held in IIT Guwahati from 30th November to 3rd of December. IISF. IISF is an initiative of Ministry of Science and Technology and Ministry of Arts Science of Government of India in association with Vigyan Bharati, which is a science movement with Swadeshi spirit led by eminent scientists of our country. The main purpose of IISF is the celebration of science by all. Engagement of common people with science in a joyful and entertaining manner is essential for healthy, prosperous, and meaningful life. So today, for this special program, we have our chief guest, Professor Gautam Shutradhar, Director, NIT Jamshedpur, with us. Also, we have Professor Dr. Shamit Guha, Department of Chemistry, Jadavpur University, and Secretary, Bibha, West Bengal, representing IISF from Bibha. I request our senior most scientist, Dr. Shitendu Mondal, Chief Scientist, CSI CGCRI, Dr. Shomnath Bandhopadhyay, Chief Scientist, Dr. Shaikadev Acharya, Principal Scientist, and Dr. Indranil Bishwas, Principal Scientist, to kindly accompany our chief guest and Professor Shomit Guha to the stage and take their seats in the dais. Sir, please. May I now request our dignitaries to come forward and begin this auspicious program with the ceremonial lighting of the lamp.
कुन्देन्दु तुषारहार धवला या शुभ्रवस्त्रामृता या वीणावरदण्डमण्डितकरा या श्वेत
ম্যাডাম হাত পড়ে গেছে এর সাথে হাত পড়েছিল রিলসটা বলতে গেছে
Now I request Dr. Shitendu Mondal to welcome our guest and all the dignitaries with the flower bouquet and uttariya. I request our student Garima and Navadita to accompany. May I now request Dr. Somnath Bandyopadhyay to kindly welcome Dr. Shitendu Mondal with flower and Uttoryo. Now, our IISF outreach program will start with welcome address. So on behalf of Director CGCRI, I request our senior most scientist, Dr. Shitendu Mondal, to kindly welcome the audience.
Respected today's chief guest, Professor Dr. Gautam Sutradhar, Director, National Institute of Technology, Jamshedpur. Respected Professor Guho, Assistant Professor, Department of Chemistry, Jadavpur University. My senior colleagues, Dr. Somnath Bandyopadhyay, Chief Scientist and Head Fiber Optics and Photonics Division. Dr. Indranil Biswas, Principal Scientist and Head Business Development and Publication Division, CGCRI. Dr. Soikot Dev Acharya, Principal Scientist and co-nodal of this particular curtain raiser program, CGCRI. Senior scientists from the division, respected teachers, mistress, my dear students from the schools and colleges, and also from this organization, CGCRI. We heartily welcome all of you. Good afternoon. Greetings of the day. Today is a very important day where we need to take an oath for the cultivation of science in your young minds. Normally, we are habituated and we used to have many festivals in different aspects. But the then Science and Technology Minister, Dr. Harshvardhan, realized that apart from many things, we need to celebrate a festival in the area of the science and technology, where all over the country, all the young children who are studying class 9, class 10, even from 6, also 11, 12, they can take part as a whole in a national platform where across the country, the different kinds of the scientific and technological achievements will be focused to bring an awareness, to create a scientific temper in the young minds. And that was the initiation. He realized that if we do so, at least a certain amount of awareness will be created, will be developed in the young minds so that they can become the scientists, technologists, to serve the country, to serve the nation, to bring the science and technology carry forward in the futuristic applications of the science and technology in the country itself, so that one day the nation, the country India, can say and can occupy a #1 positions in the field of science and technology. That was the basic objectives. We are studying in classes, particularly the 11, 12 classes, they are also doing some practical, but that's not the complete knowledge. Some kind of bookish knowledge also there, but the bookish knowledge has to be vetted practically with the practical experience and witnessing the feasibility of the proof of concepts of the science and technology being taken up by the science and technological organizations, whether it is industrial organizations like National Institute of Technology, like IIT, CSIR, biotechnology, space areas, defense areas, nuclear power energy program. Wherever you go in the country, you can see the tremendous amount of advancements in the areas of science and technology. In the recent times, whatever you have heard, whatever you have witnessed in the areas of science and technology, that's the impact and output of such kind of creating a platform where the overall scientific strengths can be brought into a single umbrella. This India International Science Festival is being organized every year. CGCRI has taken a very pivotal role in organizing such kind of event in Kolkata in the month of November 2019, where 2,575 young students have been called for to participate in this event in the form of a student science village. We need to do something. We need to create something in the area of the science and technology so that at least some of you can become and can win the Nobel Prize if you are tuned so. We have witnessed many Nobel laureates in the area of science and technology in India. So we need to keep on trying. We need to keep on going ahead, taking the science in different aspects. That's the basic objective. CGCRI is one of the very prestigious and pioneer organizations, not only in the field of glass, but also the many areas, low technology to high technology. Low technological applications to the space grid, where you have witnessed the Chandrayaan 3. There also CGCRI has organized many programs under that area and supplied many products. Maybe some of those you have witnessed directly during the first half of today's event. And that's the basic objective for lab visit program. At least you can witness, you can see. And at the end of the day, you can enrich some amount of knowledge base. What is science? Why it is happening and what for? And what is the contribution of Central Glass and Ceramic Research Institute in the areas of science and technology? And that's the basic objective for organizing such kind of program. This was CSIR has taken a very massive role, very productive role in bringing and taking the scientific forum carry forward for IISF. And every laboratory has been directed to organize this kind of program. It's a precursor program for the forthcoming India International Science Festival, which has been scheduled to be held at IIT Guwahati during November 30th to 3rd December of this year. CGCRI has developed many scientific technological achievements in the area of the specialty glass, in the area of the advanced ceramics, low technology ceramics, traditional ceramics, refractory ceramics. And one day, we can also organize such kind of event in our outreach center at CGCRI, Kurja Center, nearer to Delhi, and Naroda Center in Ahmedabad, where the low-cost ceramic technology, traditional ceramics, rural pottery, blue pottery, all these things are being developed. This is developed not only that, but also utilizing the waste materials to produce an wealth product in the areas of the low technology area, which is finding its tremendous application in the technological areas of low cost, high value areas. And that's the basic reason that CSIR has taken a waste to wealth mission program, utilizing waste, transforming it to an wealth product with a low cost but high technology area. Such a tremendous amount of excellent scientific capability and expertise is being grown at CGCRI in the recent times. You are studying the science as a basic curriculum in your subject areas. You are studying many of the things in your science stream. One of our very leading scientists, Dr. Somnath Bandyopadhyay, who is sitting on the dais, he will share some of the basic things which you are studying, but you can realize, you can visualize what is exactly the scientific reason behind it. It is an optical fiber technology. So this platform, this curtain raiser program, is basically the program where you can have a direct exposure on the actual scientific development being served for the service of the nation, of the country by the CSIR labs. Everywhere it is being celebrated. the former directors of Central Glass and Ceramic Research Institute. During their time, we have organized such a program. During that time, whatever the scientific achievements has been there at CGCRI, recently, with their wishes, with their setup, with their facility, with their guidance, with their advice, CGCRI has grown up to a certain image. And that's the basic reason that CGCRI is occupying a real and good position in the CSIR labs. So the contributions of the former directors of CGCRI is quite significant, and it is being a significant step forward for creating the building capability for creating an national and international image in the field of science and technology. CGCRI is trying to occupy a vantage positions in the areas of science and technology in the global map. All the PhD students, all the project assistants and associates, they are very keen to do the research work in the very dedicated and diversified areas. Many of the key technological research, scientific research work will bring a strong and impetus to the benefit of the welfare of the science and technology. All the PhD students who are doing the good research work in this institute are earnestly requested to capture some good ideas, to grab and proof of concept in their research work, utilize it in the form of submission of a project proposal, so that that particular division, that particular scientist can get a good proposal, good research work, good funding. Obviously, science and technology is largely dependent on the financial resources. Unless you do have the financial resources, you cannot take the scientific endeavors to that direction. Therefore, my earnest request to the PhD students who are here, of course, I do not know who are there or who are not here, but please send the message who are not here that it is also their duty not only to submit the project, the PhD thesis or other things, but also grab this idea so that you can have a good proposal for the benefit of the CGCRI, for the benefit of the division. Not only that, but also for the benefit of the scientific welfare of the country, for the nation. That's a message. It has to be there on behalf of the curtain raiser program. The students who are studying the class 12 classes, really be attentive and study the scientific things so that you can become a scientist, become an engineer after completing your class 12 studies, so that one day some of you can join at CGCRI as a scientist to serve the country, to serve the nation, to serve the organization as a whole. So that's the basic objective of this kind. I believe in the first step, you have gained some knowledge base, some practical knowledge base with the help of our scientific volunteers, while directly witnessing the scientific and technological achievements in each of the labs, and realize and tell your schools and colleges, say, yes, sir, take a program, create a program. One day we will visit CGCRI. Maybe for one day, maybe for 2 days, maybe for 3 days. So your college, your school will be an instrumental tool for the creation of your scientific endeavor, apart from efforts taken up by CGCRI, by the concerned team who is working day and night in this direction. Take an oath in this direction. Go there, discuss with your teachers, discuss with your principal, discuss with your headmistress, and you need to have such kind of program to create an atmosphere in your schools and colleges for celebration of the Technology Day, Science Day, Teachers Day, Women's Day. Many other things are there. Those are also a part of the scientific festival. We are giving much more time for the celebration of the societal and spiritual festivals. At the same time, it is equally important to give much more time for the celebration of the scientific festival, not only in your academic premises, but also in your related areas. That's a message you can carry forward. My best regards and pranams to my former directors and dignitaries. I do not know who have joined here. My sincere gratitude. that they have given some amount of time to be present, and their gracious presence absolutely will enlighten the scientific endeavors and create a scientific temper in the young minds. We are trying our level best. If anything is there, please excuse us. But we have put our wholehearted effort to make this program a grand success. My congratulations to the organizing team, who has taken a very keen interest and who has put their untiring efforts to make this program a grand success. At the same time, my sincere regards to Professor Gautam Sutradhar, Director, National Institute of Technology, Jamshedpur. Fortunately, while talking to him, he was here in Kolkata. So when I requested, sir, this is the program, can you come over for an hour? He immediately accepted our proposal. And of course, he is a family member of not only in CGCRI, but also for CSIR as a whole. We are very much thankful to sir for giving his some valuable time at CGCRI, for giving his moment for the benefit of the students' welfare, and his presence obviously will create a scientific temper in their young minds. With these few words, once again, thank you very much. And I remain so thankful to the teachers, to the mistress, who have come forward and given their consent to be with us in this particular gathering. And I wish this program once again a grand success. Thank you very much.
Thank you, sir, for your encouraging words and give a briefing about CSI CGCRI activities. Now I request Dr. Indranil Vishwas, Principal Scientist and Head VTPD CSIR CGCRI, to brief about curtain raiser event of IISF 2024. Over to you, sir.
Respected Professor Gautam Sutradhar, Director NIT Jamshedpur, Professor Shomit Guho, Assistant Professor Jadavpur University, Dr. Shitendu Mondal, Chief Scientist and Head of Specialty Glass Division, also the nodal for IISF 2024, Dr. Somnath Bandopadhyay, Head FOPD and Chief Scientist, Dr. Shoikatdev Acharya, Principal Scientist, Head ESD, and co-nodal of this IISF 2024. So I was in bit confusion that I thought I have to say something about curtain raiser or IISF 2024. But when Dr. Mondal has already been given all the details, nitty-gritty, so I have very less chance to give you more details on that. So let I start with something, asking some question to students. So did you enjoy your lab visit and all? Yes. So I can say that the basic purpose of this IISF is to enjoy the science. So you have enjoyed, right? So first purpose is fulfilled. Second one, engagement of common people with science in joyful and entertaining manner is essential for healthy and prosperous life. So hopefully when you enter in your advanced career and if you take science as your career options, you will get chance to understand this philosophy. IISF provides opportunities to people and scientific fraternity in the country and abroad to come together, to work together and experience the joy of doing science for well-being of India and humanity. So every year IISF has a vision. So this year 2024 we have a vision for IISF. So what is the vision? The vision is a prosperous Bharat in harmony with modern infrastructure and nature, giving opportunities for all citizens of all regions to reach their potential through science and technology with a theme to transforming India into a global manufacturing hub through science and technology. So this is the main theme for this IISF 2024. With an aim of Honorable Prime Minister Sri Narendra Modi ji to achieve Viksit Bharat by 2047. So started with 2015. This IISF has started from New Delhi. It started with a journey with a glorious past. So lot of people, lot of students, lot of innovators come together to share their experience. This 10th edition of this mega science festival will be hosted by IIT Guwahati in Assam during 30th November to 3rd December 2024. Celebrating the achievements of Indian scientific and technological advancement with students, teachers, and innovators, this curtain raiser program of the festival engage and all the people, showing them how science, technology, engineering play a pivotal role by providing solutions to improve our lives. Already, students, you have visited our R&D labs as well as you have seen the archives also. I feel you have an understanding on how science come up and how they are doing now. So hope you all are enjoyed very much. It is worthy to mention that in 2019, the 5th edition was hosted by this CSIR CGCRI under the noodleship of Dr. Shitendu Mondal. And also we have a rich experience to host this curtain raiser program every year. So I can say that without taking much time, we are very eager to hear from our eminent speaker. So we have with us this time Professor Sutrodhar, Director NIT Jamshedpur, and Professor Shomit Guha. Thank you, sir. Also, we have with our very own Dr. Somnath Bandyopadhyay, Head Fiber Optics. So without much delay, I can thank you all again that you all come up to make it a grand success for this time curtain raiser program organized by CSR CGCRI. Thank you. Thanks to you.
Thank you, sir, for giving or explaining the main purpose of the curtain raiser event. So now I request our guest, Professor Shamit Guha, to brief about IISF 2024 and role of Viva. Over to you, sir.
Namaskar. Good afternoon, everybody. Dignitaries on the dais, Professor Gautam Sutrodhar, Director, NIT Jamshedpur, Dr. Somnath Bandyopadhyay from CGCRI, Dr. Shitendu Mondal from CGCRI, Dr. Shoikat Acharya and Dr. Indranil Bishwas from CGCRI, dignitaries of the dais, teachers, and my dear students. On behalf of Vivekananda Bigyan Mission, West Bengal chapter of Bigyan Bharati, I would like to welcome you all in this curtain raiser program of 10th India International Science Festival, IISF 2024, organized by CSIR CGCRI. As you all know that Swadeshi Science Movement was started in IISc Bangalore.
by a few eminent scientists under the leadership of Professor K.I. Basu. During Nagpur meet in 1991, 21st October, it was decided to launch Swadeshi science movement all over the India and named it as Bigyan Bharati. Now we have 24 prant all over the India with different names. In West Bengal, it is known as Vivekananda Bigyan Mission. So what are the objectives? Propagating scientific heritage of Bharat, popularizing Swadeshi science, learning in your native language. So as you already heard that Swadeshi science movement is started at IISc Bangalore. So now I'll talk about Swami Vivekananda's vision of Indian education and science. Jamsetji Tata and Swami Vivekananda were traveling through a ship from Yokohama to Vancouver. And Jamsetji Tata realized that there was a monk. He came and interacted with Swami Vivekananda. They have discussed various aspects for the development of India. And Swami Vivekananda mentioned that we need a good research institute of science. And it was 1893. So after 5 years, so 1898, Jamsetji Tata wrote a letter to Swami Vivekananda and mentioned him to take the responsibility of IISc Bangalore. However, at that time, Swami Vivekananda was busy for the development of Ramakrishna Mission, and he didn't take the responsibility. However, he has arranged several meetings with Sister Nivedita. 4 meetings in Kolkata and 4 meetings in London. Together, they have formulated IISc Bangalore. So Swami Vivekananda's vision of Indian education and science is really important. And our chapter is known as Vivekananda Bigyan Mission. And if you go to the IISc Bangalore website, you will see the original letter of Jamsetji Tata. When Jagadish Chandra Bose returned from University of Cambridge, it was 1888, with a recommendation letter of Lord Rayleigh, a Nobel laureate in physics, to get a faculty position and to teach physics. However, at that time, it was British Raj. British people mentioned that Indians can't think in a rational manner, so he should not teach physics. So obviously, his application was rejected. However, temporary basis, he got an offer, almost 1/3 salary of British people. So he has challenged the hegemony of British people and mentioned that I will teach physics in Presidency College. However, I will not take a penny for that. And he didn't take a penny for almost 3 years. So first Satyagraha was led by Acharya Jagadish Chandra Bose against British Raj. So we know about Gandhiji, right? So in science, first Satyagraha was led by Acharya Jagadish Chandra Bose against British Raj. So in 1970, কি হয়েছিল বলো দেখি? 1917, বসু বিজ্ঞান মন্দির, right? He was the founder of বসু বিজ্ঞান মন্দির। উনি মনে করতেন শিক্ষাঙ্গন মন্দিরের মতোই পবিত্র হওয়া উচিত। So Nebeli Mott, a Nobel laureate in physics, mentioned that Bose was almost 60 years ahead of his time. So he wrote a book, Niruddesher Kahini, a short story. Later it was incorporated into Abbakto with a new name, Palatok Tufan. It is one of the first science fiction in Bengali. And Acharya Prafullo Chandra Rai, you heard about Acharya Prafullo Chandra Rai, right? He is the father of Indian chemist and founder of first Swadeshi pharmaceutical industry in India, Bengal Chemical and Pharmaceutical, in 1901. When he was a graduate student at the University of Edinburgh, at that time he was interacted with Professor Alexander Graham Brown and become a true lover of chemistry. At that time, he wrote India Before and After Mutiny, and it was against British Raj. Although he did his PhD from abroad, however, he didn't get a faculty position almost 1 year. He worked with Acharya Jagadish Chandra Bose. In 1889, he got a chance to join as an assistant professor in the Department of Chemistry at Presidency College. At that time, it was Presidency College. In 1916, he moved to Rajabhaja Science College as a first professor in the Department of Chemistry. In 1907, when Tata was established at Jamshedpur, Tata Steel, at that time sulfuric acid was required as a raw material. And Acharya Prafula Chandra Rai mentioned that I will provide sulfuric acid, and he did. Right? So this is the most important part. In 1923, during North Bengal flood, he has arranged Bengal Relief Committee, and they have collected almost 25 lakh. He has given his lab for the nationalistic work. He has mentioned science can wait, but Swaraj can't. So nationalism of science started. Another small story about his student, Biresh Chandra Guha. তোমরা কেউ নাম শুনেছো? দেখি কে যে কাউ নাম শুনেছো? Biresh Chandra Guhar কেউ নাম শোনেনি? He is the father of modern biochemistry in India, right? When he was a BSc student at Presidency College, he was participated in the non-cooperation movement of Mahatma Gandhi. Obviously, it was against the British Raj, so he was imprisoned for almost 1 month. So at that time, Principal Professor Barrow of Presidency College mentioned him to leave the college. None of the college in Calcutta accepted him except St. Xavier's College. So his rank was first class first in BSc Chemistry Honors. Then he moved to Rajabhaja Science College, Organic Chemistry Specialization, MSc. Again, first class first. কেন আমি বলছি এটা? 4000 mammalian, 4000 mammalian can synthesize their own vitamin C, right? But human, guinea pig, fruit bat, monkey, they are unable to produce their own vitamin C. আমাদের কি করতে হয়? বাইরে থেকে ভিটামিন সি বা অ্যাসকর্বিক অ্যাসিড নিতে হয়। Why? 4000 mammalian কেন পাচ্ছে? আমরা পাচ্ছি না কেন? Because in their body, vitamin C is synthesized from glucose, and there is a biosynthetic pathway. In human, we have a genetic defect. 1-gulonolactone oxidase enzyme. There is a genetic defect in the last step. So we are unable to synthesize vitamin C. কে এই প্রবলেমটা সলভ করেছিল? নেচার পেপার, Biresh Chandra Guha. He was the founder of IISF, CSIR, another institute, CSIR IISF. Right? So now, if you take a look, so I'll tell some thing. Try to realize, eh? Did you hear the noise? Right? Now question is, why? So you will learn this type of thing from IISF. If you participate IISF, there are some workshop is there, as well as contribution of Indian scientists before and after independence of India, as well as you will learn something what you can learn from nature.
So when you tear a piece of paper, you will hear the sound, right? The question is why? Because paper is made up of cellulose, right? And cellulose are intermolecularly hydrogen bonded. Physics is there, but what is the chemistry part? Yes. So when you tear the piece of paper, you will hear the sound because you are breaking the intermolecular hydrogen bonding, right? And that energy is converted to sound energy. Now you can do in your home. You do soak the paper in water for a few minutes. Then you try to tear the paper. You will not hear the sound. As well as it will be easy to tear. The question is why? Because water will break intermolecular hydrogen bonds of cellulose. Now water will form hydrogen bond with each cellulose molecule. That is why it is already broken. That is why it is easy to tear and you will not hear the sound. So madam, লক্ষ্য করেছো কিনা জানি না, if you bite on an apple and put it into the table or a bowl, after a few minutes it turns brown. লক্ষ্য করেছো? Now question is why? কে অক্সিডাইজ হচ্ছে? অক্সিডাইজ কে হচ্ছে? Why apple is good for health? Malic acid is good for health. Malic acid আছে। Lot of antioxidant. Right. Polyphenolic compound. Right. Which is oxidized in air to form quinone. That is why it turns brown. Same chemistry is going when you go to the market and cut piece of green jackfruit. After a few minutes, you will see it turns brown. What about iron? The iron not same chemistry. Polyphenolic compound oxidized to quinone. It turns brown. ওরা দেখবে কি করে লেবু দেয় দেখেছো লেবু দিলে কম ব্রাউন হয় কারণটা কি so 2H plus so equilibrium will be shifted to left side. They don't know chemistry but they have the idea of practical knowledge, right? Same chemistry is going to potato. That piece of potato turns brown but the molecules are different in all the cases polyphenolic compound. So in case of apple, catechin, epicatechin, this type of compounds are there. When you chop onions, you get tears from your eyes. Question is why? So there is an enzyme called lactylmentary factor synthase, or previously it was known as alliinase. কোথায় থাকে? পেঁয়াজের খোসাতে। When you remove the onion cell, it is volatile and it comes to the onion and there is a sulfur containing compound is there and it breaks the bond and you will get a volatile lactylmentary sulfur containing compound. That is why you get tears from your eyes. Butter and coconut oil freeze during winter. However, cooking oil remains liquid. Why? Realize for the butter and coconut oil freezes during winter. However, cooking oil remains liquid. Because in case of butter and coconut oil, there is a saturated fat, small saturated fat is there, which pack nicely. That is why it freezes during winter. However, in case of cooking oil, unsaturated fat is there, and that unsaturated fat is 6. In chemistry, generally trans is more stable than 6. But see the beauty of nature. In our body, we have 6 double bond, right? Why? Because in case of 6, it will not pack nicely. There will be a king. That is why in our body we have the 6 double bond, as well as in cooking oil, 6 double bond unsaturation. That is why it remains liquid, right? So last time একটা কথা বলে শেষ করব। So 1944 সালে the Nobel laureate in physics, Isidore Isaac Roby, I thought Isidore Isaac Roby, my mother made me a scientist without ever intending to. Every other Jewish mother in Brooklyn asked her child after school, did you learn anything today? Not my mother, you see. She always said, did you ask good question? That difference. Asking good question made me become a scientist. So this is my request to all the students, ask questions. Ask questions and ask good questions. Thank you. Hope you will enjoy a lot. Right? Thank you. Thank you very much.
Thank you, sir, for giving a brief about ISF, role of Viva, also for explaining the importance of science to our students in an interactive way. I hope everyone enjoyed. So with this, now we will have technical session by Dr. Somnath Bandyopadhyay, Chief Scientist, on the topic optical fiber and communication and sensor. Dr. Bandyopadhyay is a nationally and internationally acclaimed scientist and renowned for his contribution in the field of fiber optics and associated field. Over to you, sir.
Good afternoon. Our chief guest, Professor Shutradhar, Professor Guho, our nodal scientist Shetendu, and all of my colleagues, and especially the students, those who have joined these camps. One very important question that I need to ask at this moment after listening to Professor Guho. We nowadays, because I know that there are students from class 11, 12, and you are thirsting for joint entrance, you're thirsting for IITs, etc. With a target 90% to go for computer science, medical, yes, there are quite a few, but ultimately computer science, artificial intelligence, machine learning. Nowadays, everybody talks about that. But listening to these things and attending these camps, I think we have always been benefited to ask fundamental questions which actually inculcate science and ultimately will lead you to those high-tech sciences and engineering. We cannot jump onto those things unless and until we know the basics. So this fiber optics and communication, I will also try my best to go into that level because there are mixed audiences. I have tried to prepare my presentations without a single equation. That actually excites me to present things with more fundamental. But ultimately, when you will reach at the end of this presentation, you will see that where these technologies can go and can be applied in applications. So mostly we will hover around optical fiber. Optical fiber definitely relates to optics, and optics means the source is light. So I will start with our source of light, the sun. We all know that if you focus this, it burns paper. And we also know why it is. But we just go into one step deep. Here we are considering only the energy and the power of this source, which is used to destroy these things. But if we go into the deep of this source, we only can learn that there are different components in this white light source. So if it is simply dispersed using a prism, we see a spectrum. Means all this spectrum, this is of course visible. And if you now broaden this idea, we can go to this electromagnetic waves spectrum. Here we can have a very clear idea about this visible spectrum, what we see after dispersing white light. And rest of these UV, infrared, this microwaves, radio waves, all are used for communications, are invisible. Similarly, the X-rays and gamma rays, those are primarily used for medical purposes and all these things. If we broaden this thing. So why I am discussing this thing? Because the exact window of this electromagnetic spectrum or the frequencies which we generally use for optical communication needs to be understood very well. So we always talk about this visible radiation, which starts from this violet to red, and beyond that red there is a very nice window of infrared. The infrared wavelengths or the frequencies which are very close to red is called the near infrared band, which generally is used for optical communication. Now, artificial light sources are very important because when we come to the laboratories, we come to our daily uses, we have to develop this light sources starting from our old incandescent lamp, the halogen lamp. The nature of these lights are different in terms of the spectrum or the composition of the wavelength that these sources are there. Then the fluorescent lamp, LEDs, finally the white LEDs. Another quite different nature of light radiation or the source is the laser, which was invented in the year 1960. And then in 1962, we had our first semiconductor basics of gallium arsenide devices, which is also a light source. We all know that there are semiconductor materials of N-type and P-type, and with this basic structure of gallium and arsenide, we could generate the laser light. The nature of this laser and this incandescent or the Lambertian light source are absolutely different. We will come stage by stage. And here we see that there are certain colors of light individually, which generally were absent other than these LEDs, and where these colors of these lights are used will be discussed later on. Now, as soon as we have our different sources of light, we should have a measuring device. Generally, all these measuring devices are again semiconductor devices, generally termed as photodiodes. And if you have a photodiode, then a certain electronic circuitries those electronic engineers develop can give you clearly the amount of light power. This is very important. It measures the light power. It does not have any idea about the composition of the light or the wavelengths of light which they are having. Now, another important thing, as we have already seen, that when there is a white light source, if it disperses, there is a spectrum. Now, if anybody asks me a question that instead of measuring a power which is having all composition of this wavelength, can we selectively measure the power of each of these wavelengths? The terminology is the spectral power density. Means we have a spectrum, then you use a tiny window, scan this tiny window, again put it on the electronic processor. Finally, what we get, when we will scan, wavelength wise you will get certain powers, and in some areas you will not get any power. So what we see, these are the spectrum of this light source. I mean, it is typically shown, and each and every wavelength of light is having a signal level which is called the spectrum of this light source. To measure the spectrum of this light source, we have optical spectrum analyzer. And finally, with this basic concept, we can divide clearly the light sources as monochromatic, which is having a single light or the wavelength, or a polychromatic, which is having several wavelengths. So with this basic concept, if we have a spectrum analysis of a polychromatic source, we will have different energy levels at different wavelengths, but when they are monochromatic, that is, it is red, purely violet, as well as green, we will have only one spectrum. But when we talk about monochromatic source means single wavelength. We cannot expect that the single wavelength means a delta function, means as an arrow. It always will have a certain bandwidth. The narrowness of the bandwidth gives you the purity of the source. A few strange phenomena. You see, in +2 level or +10 level, you have done this experiment. You just consider a pointer, which I'm using. You put it on the mirror, you will get a reflected light, and tracing that light, you can draw this, and this clearly gives you the angle of reflection and angle of incidence and reflection. But the same monochromatic light, say a single frequency light, when it is put to a very small window, we generate this band pattern. Why this is so? The same light source, it is a red laser, considering monochromatic, it is getting reflected back from a mirror, and you are getting the trace as I am getting. This is also a diode laser. But when this same laser will pass through a very small and tiny slit, we will get this pattern. This is called the interference pattern. So here comes the idea of defining light. At some point of time, we define light as a quantum of photons having certain quantum of energy for each photon. And to define these interference phenomena as well as double slit diffraction phenomena, where a simple light creates a band where the reorganization of the energy in this light source is there because of this phenomena, there we need to define the light in terms of the wave. Now, optical fiber communication. We use light for communications. Communication means data transfer. Now, if I ask you that I have a laser source, now from the top of a building, say the tallest building here available, if I light a laser source, can it reach to Delhi? Why? Because two phenomena are there. There will be huge scattering, and overall the absorption of that light in the media. So it will never reach. After certain time, it will attenuate and it will be lost. So to communicate using optical signal, you need a guide, which will be almost lossless and will transmit optical signals from Kolkata to Delhi, and it is overseas also. So we need optical fiber, and optical fiber is called a light guide. What is actually the nature of optical fiber? We know that the diameter of the human hair is around 20 to 100 micrometer. It varies person to person, origin to origin. And in optical fiber, which we generally use for optical communication, it is made of glass. The central part is called the core. Around that, there is another glassy layer which is called cladding. The overall diameter of this glassy layer is 125 microns, so as comparable to our hair. And then finally, there is a jacket to protect this glass material. And when these are in the form of a cable, which we generally see, which are being laid, along the footpaths everywhere, it has to be shielded to protect and give strength. And finally, at the time of say clubbing many optical fiber into a cable, the armored cables are manufactured. See how optical fiber guides light. Can you remember the Snell's law of refraction? Water is denser than air. So whenever light passes from this denser to rarer medium, up to a certain angle of incidence, it will be confined to this, then it will have a total internal reflection. Now, this Snell's law, if we now see this optical fiber, if we slice it and see this, so just lengthwise we had taken a slice. The central part is the core. As I told you, the core refractive index is slightly higher than the cladding refractive index. So there must be a certain angle of incidence of the light for which this light will be trapped within this guide and will now start communicating without any loss. So this is the basic principle of trapping optical signal in optical fiber, and where it is used for optical communication. Now, to have certain typical values, you will definitely ask questions that this core is also made of glass, clad is also made of glass, and these two have refractive index differences. Clad is lower than the core. What is the range? Typically, the value of the core material is 1.456 around, and the cladding material is slightly low, 1.454, and it depends on the composition of the fiber. But these are all the typical and practical values I am talking about. Now, optical communication versus electrical communications, why we generally go for optical communication? We know that nowadays, with the necessity of larger and larger communication bandwidth and the channels, internet, etc., we need to pump more and more information in the communication channel. In in electrical communication, we generally use, or the electrical cables, we generally use electrons for propagating the communication or the data. But in optical fiber, the photons or the light is used for data communication. We can easily see that the total bandwidth of these optical channels are much more than the electrical. It is having the lowest or the minimum possible loss. And most importantly, why this optical fiber wins? Because we know that there are environmental interferences where a very high electric or magnetic fields are present. So whenever there is an electrical signal which is not properly shielded, it will interfere with this environmental electrical and magnetic field, and there will be degradation and there will be noise in this signal. But in optical signal propagation, it is absolutely free of that. Now, in modern optical data communication, so what will the picture of that? We start with our telephone or the mobile, whatever it may be. Then, along with that, the digital information, the internet information, etc. Ultimately, this part is the electronic part in the transmitter. Finally, all this coded form switches on and off the light source, and then this pulse light is propagated through the fiber optic cable, and in the receiving center again there will be decoding of this optical signal, and finally the signals will be transmitted. So ultimately this communication channel is nothing but this tiny optical fiber having 9-micron core diameter where your all information is trapped. You cannot do communication as of your own design. There is a very strict rule where you can see that the wavelengths which I have talked in the very first slide, the wavelengths that is allowed for communication is from 1530 to 1565 nanometer. So we are just beyond red light, and in near infrared region, it is called the C-band communication. In this, we have 44 dense wavelength division multiplex channels. Means in an optical fiber, simultaneously you can put all these wavelengths, they will never interfere. So here lies the basic importance of using optical fiber over the electronic communication cable, because each and every color of light will have information, and you can have 44 different colors in stipulated DWDM communication system within C-band. Simultaneously, you can pass it through the optical fiber. So enormous data processing or data transmission can be done. In the same system, when it propagates, I have told that the optical fibers are having low loss. Low loss means it is having a finite loss. So at some point of time when it is traveling from, say, Kolkata to Delhi, say 1300 or 1600 kilometers, there will be certain attenuation. So what we need to do, signal attenuation means you have to have a signal regenerator. Signal regenerator is nothing but an amplifier, and this particular type of thing where now CGCRI is concentrating, we see that when the optical signal becomes weak, we need an optical amplifier. Why optical amplifier? Because this amplification is done in optical domain itself. We are not converting this optical signal to electrical signal, and we know in our sound system, whatever I am talking and all these things, it is going to you through an amplifier, which is an electrical amplifier. So to amplify a signal, this optical signal needs to be converted to electrical, and again electrical amplification, again conversion to optical. Without doing that, we can have a very special type of optical fiber where if it is pumped, with another wavelength, the signal wavelength which is carrying the information will get amplified, and within this channel only, without any conversion, it will get amplified and will go through. Another very important part is when all this fiber, when once you have impinged source or the light signals in the fiber, it is confined. How you will take out these signals in intermediate sessions? In electrical cables, it is very easy. You remove the, say, shielding and then tap another wire, use a connector, you can get the signal. But in optical fiber, it is not that easy. So we need to have an add drop multiplexer, another optical component. So say these ABCD4 wavelength channels are propagating a long haul communication link. At Durgapur, you are, say, getting down this or dropping this B and D channel for their local communication. And from there, again, you want to add two more wavelength, and all these things is happening in this optical multiplexer and demultiplexer. Finally, in the main long haul cable, you will find this AECF, means EF, which is uploaded, and A and C, which was passing through, will go through. I mean, these are all the basic ideas, but these devices are nowadays available. CGCRI is working, I will come down, where this particular type of thing CGCRI is also developing. And ultimately, the product which shows in a telephone exchange or in communication system is a compact package system of OADM. Now let us come to this optical fiber. We have discussed few basic things about communications, where the prime importance is we want to communicate light signals and transfer this light signal with minimum loss and minimum, say, disturbances in the channel. Otherwise, all of our data, communications, everything will be lost or will get disturbed. In optical fiber sensor, how it works? So why we are going for, first question is, definitely you will ask, why we will go for optical fiber sensor? What a sensor does? Sensor is a device we generally get. We have sensors. So in physical measuring system also we have sensors. Generally for measuring strain, temperature, vibration, pressure, there are electrical sensors available. So naturally you will definitely ask question, why we will go for optical sensors? Let us go to these examples. Say you have to put a particular type of sensors in a very high voltage environment where the voltage around your sensor is, say, 25 to 50 kV. So in that voltage level, if you put any electrical sensor, it will immediately go off. It will never work. Similarly, in power generators, within the generator, the magnetic field, like in our MRI machines, the magnetic field within the generator is around 2 to 3 Tesla. If you try to put any electrical sensor in that high magnetic field, it will stop functioning. So in these particular very special type of applications where the electrical sensor fails, you need to find out an alternative. So who is going to help you? The optical sensors. How it works? You see, we have discussed about optical fiber. It is just a side view of this optical fiber having the same port diameter and a cladding. What we do now? We, along this length of the fiber within this core, we have drawn a few dark spots. What we have done? We have again, we discussed that the core or the central part, it is having a refractive index N1, which is slightly higher than that of the clad, and the light will be confined always. So in the core, what we are doing now, again, we have discussed about interference of monochromatic light. So what we are doing, we are using a monochromatic light, creating an interference fringe. Interference fringe means the light, monochromatic light is being distributed in brighter and darker fringe. And now I am putting my optical fiber sidewise in this fringe, exposing. What will happen? This pattern will get embossed in the optical fiber. What it will do? This particular wavelength of light will get absorbed in the optical fiber core, but where it will get absorbed? where the brighter spots are there, the core material will get absorbed. So locally at this particular brighter spot, I would be able to increase the refractive index of the core with a certain value. Where there is no exposure, that is the dark spot or the dark line, the refractive index of the core will remain same. So ultimately, after exposing this, we can assume that we could generate a refractive index layer or the periodic layer, where in certain region the refractive index is higher, and in other regions where it was not exposed, the refractive index remains same as the core. So we could form a particular type of periodic structure, and that structure is called a Bragg grating structure. Now this is very important. Now you infuse a light with a broadband and have your Bragg grating. So instead of transferring all this light, which generally is done for communication, what will happen? Each and every Bragg grating, which is characterized with its period, as I have created, will reflect a particular band of light. So within an optical fiber having core 9 micron, I could create a reflective mirror. So a mirror is embossed in the form of this periodic structure within the fiber, and that is that is giving you the reflected light back, and where the lights are not reflected, the rest of the light will pass through. Now the question is, this grating structure, how it will give you a sensing mechanism. Grating is made up of silica fiber, and the silica fiber is having two very important parameter, which is called the photoelastic coefficient of material and thermo-optic coefficient. What does these two mean? Means if you simply pull the fiber, means you are straining the material, your silica material will have a change in refractive index. And when you raise the temperature around this grating, your thermo-optic coefficient of the material will change the refractive index. So if we go back to this basic simple equation, the Bragg reflected light was a product of the refractive index and the period. We have created the period. Now, either by pulling the fiber or by heating the fiber, we are changing the effective index. So we can expect the change in this wavelength, and that is giving us the signal which we are measuring in terms of the change of this grating characteristics. Now, this characteristic, once you are with a device which is sensing temperature as well as strain, so you can devise a lot of other sensors which you can say derive and engineer based on your design. Say, let us come back with a basic mechanics, and if you see that if I take a cantilever, if I take a cantilever, this is a simple plate, and now if I start displacing it, so you force this cantilever, there is generation of a strain. So in the next step, what I am doing, I am putting a Bragg grating on this area where it is getting strained, and now you start vibrating it. So definitely the Bragg wavelength you had it in the parental form will now start oscillating. So what you are doing, you are measuring this oscillating Bragg wavelength shift using your spectrum analyzer, as we have already learned. And ultimately this vibration frequency is giving you the vibration of this cantilever. And who is vibrating the cantilever? Any structure, maybe a vibrating machine. You are putting your vibrating sensor on a vibrating machine. Ultimately, you are getting the optical signal which is being a time variance. And finally, after getting the signature, you can measure the vibration. So using this principle, what we have done, we have developed here at CGCRI, these tiny optical vibration sensors. All these vibration sensors were characterized and ultimately were put in a generator of NTPC power generator, where they are measuring, this is the overhang, that is the stator of a generator of say 500 megawatt generator, which is used for electricity production. And this, when the rotor rotates, this generator overhang vibrates, and they do not have any means
to measure the vibration of this overhang. So these types of optical vibration sensors were put in NTPC generators, and we could measure in this say high magnetic field environment the vibration of this generator. So these are the sensor placement. Finally, the graphical user interface sitting at the control room, you could measure the vibration of this overhang. Now, there are different other types of vibration sensors. So as you are now in the design phase, so mechanical engineering, the designs and all these things will come, and you can develop various different types of vibration sensors. Now, the application of strain sensor, another very interesting application that I want to give you is the measurement of the strain of or that overhead traction monitoring of Indian Railways. I hope you all have seen a pantograph. Pantograph of a railway loco, either in a local train or in engine, there is a pantograph which collects current and runs the engine. So now the pantograph is always in contact with the overhead line. When the loco moves, it has a friction. So actually, have you ever seen that the wear always moves? If this is the bow of the pantograph, the wear always moves on the carbon collector that is on the pantograph. Have you ever seen? No. Why this is done? Because say the loco is moving and the wear is in touch at a particular location, miles after miles. So what will happen? There will be abrasion at a single place. So unnecessary the carbon collector which is collecting the current of the pantograph from the pantograph will get damaged and will be degraded. So what they generally do, they stagger the poles. So the stagger the poles means the wear is moves in this direction, in this way. And when the pantograph moves, the wear actually moves over the pantograph. And this is the 550 millimeter range in Indian Railway standard pantograph where this line moves. And from this, you know that the pantograph is in touch with that overhead wear. So there is a contact force. If the force is higher, then it may break the pantograph. If the force is very low, then it may get detached. Have you ever seen that sometimes there are sparks when that loco moves? Why the sparks are there? Because there is a detachment of this current collector from the wear. That is also detrimental because whenever there is a spark, there will be a local heating on the pantograph, and ultimately, again, this carbon collector will be destroyed. So what we could measure in using this method, we have to measure the contact force between the pantograph and the contact wear. It is for monitoring purpose. Then the contact position, where it is within the permitted region or your pole is displaced so that it is moving away from your pantograph. Next is the impactor location, say any unwanted thing, it is hitting the pantograph. And finally, the height of the wear. So what we have done, you see, the journey of developing these types of sensors with a basic fiber optic sensor, we started analyzing this. It is a finite element, so gradually we are moving up. You see, with this analysis software, we can clearly analyze that on a standard pantograph, if we load it, where are the loading points and how the pantograph is trained. Second, you have to package your sensor because the fiber optic sensors which we are going to use is a glass fiber having 125 micron. So if you simply, just shake it vigorously, it will break. So it cannot be used in that pantograph. So we have to have a package. This also had been designed. Finally, we make these sensors. It was implanted in the pantograph in our lab where we had simulated the experiment, how the pantograph moves. Finally, the railway people only will allow you to hoist or use these sensors in railways at 25 kV. If this is validated at high voltage test environment. So we had done all this high voltage measurement of our sensors. Finally, we got this tower wagon from Indian Railways, deployed the sensors on a pantograph, and this pantograph, when runs, gives you real-time data of this contact force of the wear on the pantograph. The location is changing. We are getting the contact location. Then when the wear moves down the bridge, its height is reduced automatically by the overhead lines. You can see that the pantograph is now coming down, and here you can see this is the height of the pantograph. It is coming down. When it will go below the bridge, it will come at around 0.5 meter or so, like this. So these are all the real measurement that is being done, and again it is going up. So in this environment, if you want to use a sensor, you cannot do with any type of electrical sensor. So we are simply using optical strain sensors, deployed the strain sensor with proper understanding where mechanics comes, where software people are contributing, where the decision makings are based on AI, and finally the packaging of the instrument what we have done, it is also having certain aesthetics. So a complete team and the expertise is required, starting from the very basics of your optical fiber sensor creation, and the characterization of the optical fiber. So this is what we generally do in our department. I think you have all visited, but unfortunately we could not make provisions to demonstrate you all the facilities because of shortage of time. But we had developed different varieties of optical fiber sensors which are being deployed in different applications. And facility wise also, unfortunately, we could not demonstrate you everything. There was a demonstration on screen, but we have world class fabrication facilities or optical fiber as well as optical fiber sensors. We have all the characterization facilities, etc., in our lab. And finally, all these things we are doing starting from the very basics of understanding about using the type of optical fiber. Means it is not that, and not straightforward, that you jump onto the software part, you jump onto the decision making. If you have been given or asked to solve a problem, you have to start from the scratch, that what type of sensors you have to use, what are the basic physics that will be there behind this, what are the parameters you need to measure, and finally the decision making and representation of the data. So that is what we are doing, and it was our effort to give you a comprehensive idea that what type of research and development. It is only one division that we could present to you, but with the basic thing and the basic idea which we wanted to say convey to you through these types of camps. Most important is you start thinking, you get the exposures, the things which are being indigenized, which is very important. All these things are in different form, are available globally. People can easily import things, people can deploy these things, but maintaining and surviving on these imported things and procured things is difficult. All the users and the stakeholders, like the power sectors, like railways, they start importing things, and finally at one point of time they understand and they all realize that unless and until we develop our own thing, we survive on our intellects and we survive on our development, it is not possible. So basic thing is, let us all in a concerted way try for developing new things for our country, and with basic ideas, basic understanding of the physics, chemistry, mathematics, whatever the things. So this is what we wanted to convey you. Thank you very much for your patience.
Thank you, sir, for your informative scientific talk. I'm sure now every one of us know what is optical fiber and its application in communication and sensor applications, right? Here, I think we can take a few questions. If you want to ask anything regarding the topic, you can ask. One question we can take. Okay, we can take at the last. So I now request our senior most scientist, Dr. Shitendra Mondal, to kindly formally introduce our chief guest, Professor Gautam Sutradhar, to the audience.
Thank you, Bornosri. Yes. So, we are eagerly waiting to listen to our honorable chief guest, Professor Gautam Sutradhar. But as you can see that he's with us, but from which position and what is his current position, you need to know that. Why you are leaving on? Why you are leaving? Hello? Why you are leaving? Huh? Please be seated. Please be seated for half an hour, please. Our program has not yet been ended. Please. একজন বিজ্ঞানী মানুষ, একজন অত্যন্ত বড় মাপের মানুষ, যিনি আজকে আমাদের মধ্যে আছেন, তিনি কিভাবে বড় হয়েছেন এবং কিভাবে একটা খুব বড় গুরুত্বপূর্ণ জায়গাতে উনি বসে আছেন, তার সম্পর্কে যদি আমরা একটু না বলি, এখন তোমরা পড়াশোনা করছো, উনিও একদিন এরকম ভাবে পড়াশোনা করেছিলেন, আমরাও কিন্তু পড়াশোনা করেছিলাম। কিভাবে উনি নিজেকে এরকম ভাবে তৈরি করেছেন একটা জায়গাতে, সেই সম্পর্কে তোমাদের না জানলে তাহলে ঠিক ক্রিয়েশন অফ সায়েন্টিফিক টেম্পারটা কিন্তু অসম্পূর্ণ থেকে যায়। প্রোগ্রাম আমাদের এখনো শেষ হয়নি, অনেকটা বড় প্রোগ্রাম আছে, কিন্তু এইগুলো তোমাদের জানা দরকার, শোনা দরকার। এবং সবার প্রথমে ধৈর্যটা হচ্ছে সাংঘাতিক বড় পরিচয়। ধৈর্য রাখতে হবে, ধৈর্য ধরতে হবে এবং ধৈর্যকে সহ্য করতে হবে, তবেই না আমরা বড় হতে পারবো। আজকে যিনি আমাদের প্রধান অতিথি আছেন, প্রফেসর ডক্টর গৌতম সূত্রধর, উনি বিআইটি মেথসটা পিএইচডি করে কারেন্টলি উনি আমাদের ন্যাশনাল ইনস্টিটিউট অফ টেকনোলজি জামশেদপুরে ডাইরেক্টর আছেন, আফটার এ সাকসেসফুল টার্ম অ্যাজ ডাইরেক্টর ন্যাশনাল ইনস্টিটিউট অফ টেকনোলজি মণিপুর। ওনার রিসার্চ স্প্যান্সটা মেটাল অ্যান্ড পলিমার ম্যাট্রিক্স কম্পোজিটে উনি টাইম দিয়েছিলেন। এনভায়রনমেন্ট ফ্রেন্ডলি মেটেরিয়ালসের উপরে উনি গবেষণা করেছেন, মেটাল কাস্টিং প্রসেসেসের ক্ষেত্রেও। 125টা ওনার গবেষণাপত্র বিভিন্ন জার্নালে, ন্যাশনাল অ্যান্ড ইন্টারন্যাশনাল জার্নালে উনি পাবলিশ করেছেন। ভাবতে পারো 125টা পেপার, এবং প্রায় অ্যাবভ 50 ন্যাশনাল অ্যান্ড ইন্টারন্যাশনাল কনফারেন্সে ওনার গবেষণাপত্র প্রশংসিত হয়েছে থ্রু ডেলিভারেশন। উনি দুটো অথার বুক করেছেন, ডিজাইনিং অ্যান্ড ম্যানুফ্যাকচারিং অ্যান্ড ইন্টিগ্রেটেড অ্যাপ্রোচ অ্যান্ড ফাউন্ডারি প্রসেস ডিজাইন, এবং তিনি দুখানা ইন্ডিয়ান পেটেন্ট অ্যান্ড 1 জার্মান পেটেন্ট আছে ওনার ক্রেডিটে। উনি একজন ডেডিকেটেড মেন্টর, সুপারভাইজ 20 মাস্টার অফ টেকনোলজি থিসিসেস এবং 21 জন পিএইচডি স্টুডেন্টকে উনি সুপারভাইজ করেছেন। So he is a supervisor of 21 PhD students, contributing very significantly to the advancements in material science and technology. খুব বড় বড় মেজর রিসার্চ প্রজেক্ট উনি ডিল করেছেন ওনার এন্টায়ার একাডেমিক প্রফেশনে। যে প্রজেক্টগুলো ফান্ডেড হয়েছে AICTE, CSIR, UGC, DST, including the Smart Foundry Initiative under Make in India program. His industry contributions include developing cast components for Indian railways, automotive, and earth-moving sectors, and he actively supports new entrepreneurs in the foundry field. Uni is a fellow of the Institution of Engineers India এবং অনেক অ্যাওয়ার্ড পেয়েছেন ন্যাশনালি ইন্টারন্যাশনালি, 2 বেস্ট পেপার অ্যাওয়ার্ডস and the long standing contribution in IIF Eastern Region Award in 2023. উনি একজন board member in IISWBM as AICTE nominee, Academic Council member of Central University of Jharkhand, member of Engineering Evaluation and Accreditation Committee of Tier 1 Institution of NBA. এরকম একজন আমরা প্রফেসরকে আমাদের মধ্যে পেয়েছি এবং ওনার বক্তব্য শোনার জন্য আমরা অধীর করে ওয়েট করছি। And I request Professor Sutradhar to talk on his topic, Viksit Bharat at 2047. Sir, please.
Thank you, Dr. Shitangsu Mandal. And I also thanks to the management of this institute, Dr. Naresh Chandra Murmu, who is the director of CMRI and also presently director of this institute too, until the final director from Basu, IISF Bangalore, joined here. And I'm really here. I'm really proud to be here because I am basically faculty of Jadavpur University still now. And I have long relation with this institute. And I'm really thankful to the management again because I get the scope, the chance to share my views, particularly the school and college students. My deliberation is for them only because what is happened during the last 1 decade of our country and what is the future, scientific future of the country, so that they can save their thoughts. I have some submission to professors, how Professor Guha, the same story, what he was telling, that Swami Vivekananda ji was traveling with Jamshedji Tata. One part he has highlighted that IISF Bangalore, how it has been started with the inspiration of Swami Vivekananda to Jamshedji Tata. But one part he has missed or he has deliberately didn't tell. I think you have missed it because Jamshedji Tata at that time was doing the business of textile threads. শাড়ির ব্যবসা করতেন, মানে কাপড়ের মিল, সুতো, তার ব্যবসা করতেন। Swami Vivekananda actually told him, see, we in our country there is no steel found factory. So a country's development depends on the steel usage. So in our country, as there was no steel factory at the time, so steel was coming from England, but the raw material was going from India, and that has been processed there. Making steel and other components all are coming from at that time from Europe, England. So Swami Vivekananda inspired Jamshedji Tata to start the first steel plant in India. And that is the Jamshedpur, Tatanagar, that is the first steel city in India which started producing steel. You should understand, you should at least know this thing, this fact. 1912, the first steel production in India started in Jamshedpur only. And now, second part is that here I think at least 50 children is there. But I am very sure out of that only, very few will get succeed in their life because what is the reason? As a teacher, I have already 25 years in teaching and profession. I was there. Same thing is taught in the class by the same teacher. Some of them begin the first, second, third, fourth, fifth, doesn't matter. But maybe out of that, only one person becoming the CEO of the company or head of the institute or head of the organization. What is the reason? Same input, same ambience. The thing is that if you can remember the first slide or Dr. Banerjee. I don't know. Can any one of you tell me what was the first slide? What was the first slide of Dr. Bandyopadhyay? I am asking you because I want to translate the science into in the real activity or real understanding so that you can shape your future. The first slide was sunlight as a whole. We are seeing the sunlight every day, year after year. But when it is became focused with the help of that lens, convex lens, then only it burn the paper. I want to point only that part of the slide, first slide. If you can focus your thoughts, then only you can burn your desire or you can fulfill your dreams. Am I understandable? Am I connecting to you? So that is the thing I want to, because today's program, CGCRI is providing you the facility to make your dream not for enjoyment. I'll not ask you whether you enjoy or not. I'll ask you whether you have set your dream after seeing this so many things, scientific environment, or you ultimately, your dream, can you make it focused? That is my question. And CGCR has given this opportunity on the occasion of that what is that curtain raiser program, which is a part of the India International Science Festival. So these are one of the part. But the main thing is that is the reason only 1% or 0.1% students are coming to the top of the organization or top of the any multinational company. Because the thing is that if you have to be focused, otherwise everyday sunlight is there, many papers here and there, but nothing will burn. Now my basic objective is that because you are the future of our country. So I thought when I heard that I have to say something in front of school and engineering college students, I thought for them that Viksit Bharat or coming India at the rate 2047 is very important, because at that time they will be almost middle age. So I am just asking a question to all of you, particularly students. Have you heard Viksit Bharat, the word at least? Have you heard, any one of you have heard or not? If you heard, no issue. If no hand is coming, raise. I thought that he only do not know the what is Viksit Bharat. Have you heard that? Heard, huh? Good. I expect that all of you should at least heard what is Viksit Bharat. And then they can shape their dream. They are not for, if any one of you are coming to your the best position, then it is our proud. Am I correct? It is proud of Calcutta, proud of West Bengal, and proud of India. So that's why I am giving you some thoughts, some views, some data. I think what at least after going out from this door, you can say at least I have seen some data which I have never thought from anywhere else. I normally do not put any slides if it's not a very scientific figures and the things are there to understand. So I thought I will not go into details of any science and technology. I only give you some fuel to you so that it can inculcate in your mind scientific logics to your mind, and so that you can go out of that. See, India last one decade almost, it is maybe 2014-15 to now, 9 to 10 years. I will give some advancement or something which is very important for you. So I can say that India is now moving a era which I call the threshold age. You know what is threshold? Frequency, threshold age, like that. And it is one of the best monumental moments or years in Indian history. Why? You may or may not know that India at presently is the 5th economy in the world. You know, I think. But do you know that within next 5 years, it is going to be one of the third? US, China, then India. That means it will be one of the third. That means there is a huge future for you. But you means you have to be again focused and you have to burn the paper. So just I'm telling you. And in 1947, if I say your average age is around 20, so around 47 means another almost how many? 23 years. So it is you will be around 43. So at that time, it is expected that our economy will be almost 30 trillion Markin US dollars. So your lifestyle, your coming society, everything will be abruptly changed. That we can expect. Next. Now, you may have also heard that TV or different lecture that it has started from 2022 when we completed our 75 years of our independence, that we are under Amrit Kal up to 100 years. That means another, say, 23 years. So what is the government's priority? You should know. Because you are the tomorrow's citizen, valuable citizen. So this next 23 years, government is giving 4 priority. First one is the youth. Second one is the poor people. They also think. Next is female, Mahila, and last is the Krishan. These are the 4 major objective or focus area of the government for the next 23 years. Then what from the government is doing? Just few months back, last year, December, our Honorable Prime Minister has given a talk that is known as the Voice of the Youth, where he mentioned and try to understand the youth. Yes, you are our next generation. You should know the ins and outs where we are, and then only India will go for the progress for the next 23 or 24 years. Just I want to give you some of the data which I collected from the different sources. Last 10 years, if you know or do not know, I am telling you there is a huge change in the educational system. I am not going the details of new education policy 2020. I am not going details on that, but I'm just telling you, in the last 10 years, the total university, IIM, engineering colleges, at present it becomes, if you know the figure, you will be astonished to know. If you just get a benchmark 75 years back, there was only 9 universities. At present, university number is 1,111. And that is in January 24. If you think that colleges it is 44. I am not giving the exact data I am having. It is 44,000. If you see and think how many standalone universities, institutes like IITs, NITs, other standalone universities, institutes, their number is around 12,000. And enrollment in graduates, that means after class 2, it is around 4.33 crore. Graduates are entering into the, but gross enrollment ratio is not very high. That is, final output is around 28.4. Now, if you think that what is the differences of health sector, there's a huge change has happened during last 10 years because of government's Ayushman Bharat program. And that actually makes the poor people who are particularly in the villages, you just astonished to learn that in Ayushman Bharat for the Garibs or the poor, there are 1,56,000 centers for their treatment. Now, there I am not. There are all datas are there in different policies of government like Anganwadi, like Pradhan Mantri Garib Kalyan Anna Yojana. There are many things are there, but one thing I want to mention, that is the initiation from the government of India of the Khelo India. It is basically for the players, and you just feel that this time India has got Asian Games around 100 plus medals. Then I am coming to the fact which you know, that is the Chandrayaan. Now the last Chandrayaan, which actually conquered the south pole of the moon, I think you people all knows that all world has seen the excellence of science and technology, particularly the exploration of the India's attempt on that. Now, I am just giving you one data. Those students who are basically in the science or communication, I am just giving one data to them. I don't know whether you have idea or not. In India, we're having around 140 crore of population. I'm just telling you, in this population, we are having at least 120 crore mobile phones, and which is highest almost in the world. And this 120 crore mobile phones are using, and if you see the internet users, it is also highest in the world. 80 crores. 80 crore people are using the internets in our country. And if you see that digital transactions, it is also highest. It is around 10 crore transactions per month. So you understand that digitally how the India is going faster than the other countries. This is a very good sign. Now, if you think that for the development of a country, yes, digital is one part. Another part is communication, road communication, rail communication, air communication. I'm just giving you data to the young people so that they can understand. See, in rail connection, last 10 years, normally, just take data, I'm giving it for roughly, motamoti. That normally, before 10 years, government of India is making 1,500 kilometer track, मान लो 1,500 kilometer track, railway track. Now it is coming 5,000 kilometer plus. Understand that means how many network is going faster rate. India is networking with the different cities. So in railway track, in 10 years, it becomes threefold. If you go for the national highway, the national highway length 10 years back was motamoti 1 lakh kilometer. Highway, national highway. I am not talking about the normal roads. I am talking about the national highway. It is 1 lakh. 1 lakh, 1,000 something. But now it is 1,60,000. That means 60% increase in 9 years. And networking, road networking, almost India is the second highest in the world. Around 64 lakh kilometer road network connectivity. So you understand the future of civil engineering. Okay. So road connectivity is still increasing, and it is after US even more than China. Now I am telling you air connectivity, which young people are more interested on that. I know. See, the air connectivity is going very, very higher rate in India compared to other underdeveloped countries. For example, just 10 years back, it was It was 74 or something, but now the total airport is around 157. So anyway, what I mean to say that the domestic as well as international passengers is improving. Domestic improvement is around 6% and international is around 14%. So India is going very fast rate, the air connectivity, and this aviation sector is very, very, you can now more safer as per the applications of AI and ML, artificial intelligence and machine learning. It has become more safe and more easily operational conditions. Now, next is that, so if India become the global leader in manufacturing, which is our prime importance or prime goal, please listen for another 5 minutes. I'll close my speech by another 5 minutes. I'll close it very, very briefly. So the thing is that I don't know whether you know apart from the engineering student VLSI. What is VLSI? I don't know whether school children know or not. This is a very, very integrated circuits and very complicated, and it is a very minute scale. It will be done. So it is called basically VLSI, because VLSI development is very, very important. Otherwise, our India cannot grow further, because this market is mostly occupied by China, South Korea, and other countries, Japan. But now India has taken a very good initiations for that semiconductor mission chip to start. That means there is a very, very visionary initiative of our Prime Minister that if we have to do something on the industry 4.0 or 5.0, that means mechanized automations, highly automated manufacturing industry in future, we have to be very, very sound in semiconductor as well as the communication system. Okay, that is faster communication system, that is which you call 5G, 6G communication. Now India is now giving at least huge investment on this. For the particularly engineering students, I want to say that now government has given 100 laboratories, including some institutes. NIT Jamshedpur is one of them, and try to make the highest 5G and 6G laboratories just to support the not only the institute but also institutes nearby, even schools. So 5G, 6G technology is a very, you can say, coming, and it will definitely transform the digital landscape of our country. It will definitely change. And next, our main challenge at this moment is that two areas. One is cyber security, that our India so far is not very good in that, but cyber security and digital, data analysis, these two things, India should try to cope up with the experts so that our next generation could be, because whenever the 5G to 6G technology will come, huge data transfer for different issues from the production, personals, banking sector, every sector. So huge data connectivity will be there. And for that, digital India, what I am telling, in that cyber security is one of the major theme for that. And cyber security and the data management, these two subjects actually from the academic management as a head of that, we are thinking how to improve our future generation with this cyber security and data analysis management system, so that our country will be safe from the all corners or all sorts of cyber problems. Okay, so now I want to one thing, just finally I want to say that today's context, the main technology which actually on hand the total system will be there. One is VLSI, another is IoT to cyber security, electrical vehicle, and future communication 5G, 6G. These 5 subjects will be the thrust areas for the next coming at least 20 years. So in conclusion, I could say that harnessing the power of emerging technologies and nurturing the talent and fostering the conducive ecosystem, India becomes the global leader. Thank you very much. Thank you for inviting me. Thank you.
Thank you, sir, for your talk on the current developments of our country and our target towards 2047 Viksit Bharat. So with this, thank you once again, sir. So on behalf of Director CGCRI, I request our senior most scientist, Dr. Shitendra Mondal, to felicitate our chief guest, Professor Gautam Shutradhar, Director NIT Jamshedpur. I request Garima and Navanita to accompany. We'd like to felicitate our guest by presenting shawl, memento with a book and flower vase. Please give a big round of applause for our chief guest. Please be seated. Students, please be seated. We have a group photo session after this. I'd like to mention that the flower vase is made by the beneficiaries of Khurja and Naroda Center of CSIR CGCRI. Now I request Dr. Shitendra Mondal to kindly felicitate our guest, Professor Dr. Shamit Guha. We'd like to felicitate our guest with shawl, with book and flower vase. Students, please be seated. Thank you, sir. We would like to conclude with a vote of thanks by Dr. Shoykot Dev Acharya, Principal Scientist, CSIR CGCRI. I'd like to request him to kindly present the vote of thanks.
Respected Professor Gautam Sutrodhar, Professor Somit Guho, our Director Dr. Murmu, Dr. Shitendu Mondal, Dr. Somnath Bandopadhyay, Indra Neil, all my senior scientists of this institute, dignitaries on the dais and in this auditorium, staff members, students, teachers, ladies and gentlemen. I'm really humbled to be in the organizing committee who is monitoring this curtain raiser program related to IISF. Now you all have understood IISF, curtain raiser program, everything. And the instruction has come from Council of Scientific Industrial Research, the parent body, in a very short notice. So this curtain raiser program, what we have to organize in a very short span of time. And we have requested our chief guest to be the chief guest of this event in a very short span of time. Thank you very much, sir, for agreeing and giving your consent to be the chief guest of this organizing event pertaining to curtain raiser event. We are also thankful to Professor Somit Guho, who is actually the Secretary Biva of West Bengal part, for agreeing and giving us a very mind-boggling lecture. Thank you, sir. Thank you very much. Dr. Murmu is always associated with us, our director, and taking care of all the programs that we are performing. Thank you very much, sir. And Dr. Shitendra Mondal, who doesn't require any time, always counts minute to minute advancement of the program. And his perfectionist attitude lead us to successful organizing this curtain raiser event. Thank you, Shitendra. Dr. Somnath Bandopadhyay, for his very scientific and thought-provoking lecture. Somnath actually agreed a day before yesterday, just yesterday evening, to deliver his technical address. So thank you, giving a very big hand to Somnath. Indranil, myself, my colleagues, all the members of my organizing committee, those who are directly or indirectly involved, I am thankful. I also wish to thank to the supporting sections, particularly ESD, computer, and others, those who are directly or indirectly involved, and the students, particularly those who arrived here right at the early in the morning, 9 o'clock, for a strenuous effort. We from the organizing committee, on behalf of this organizing committee, we express our sincere thanks and gratitude. Those who are present and those who are in virtual mode, we express from the organizing committee, we express a sincere thanks and gratitude to each and everybody who are directly or indirectly involved to make this program very successful. Give all of them a big hand, and thank you very much, sir. Thank you.
With this, we have come to the end of the program. I thank everybody present here to present here and to make this occasion indeed a memorable one. Thank you all. So I request everyone to stand up for national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल गंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Thank you all. So I request all students and all HODs to come on the stage for a group photo.